Hello everyone, welcome to another GIS lecture video. And in this lecture video I want to talk about this idea of distance. So how do we measure distance? So we are actually going to talk about two different ways to measure distance. We'll talk about great circle distance and linear distance. And I think given that linear distance is a little bit conceptually easier, we're going to start with linear distance, even though in the notes it was numbered 4. I want to start there because I think it'll be a little bit easier conceptually to get your mind wrapped around. And then we can talk about great circle distance and the difference between the two. So if we give ourselves a little bit of room here, I want to talk first, or recap first, this idea of Cartesian coordinates. The fact that we can describe a location instead of with angles relative to the equator and the prime meridian, we can describe them with x's and y's, which are measuring distances from an origin. In this particular case that we went through, we kept the origin as the intersection of the equator and the prime meridian for simplicity. Again, in future videos, we'll talk about map projections that don't necessarily keep the origin there, but that's for a separate set of videos. For now, keep in mind the fact that we have our locations described as distances in x's and y's from some origin. Okay, so let's go ahead and let's talk about linear distance. Linear distance. So say we have location A, and I'm going to keep the coordinates small just so that we're able to manage them. Keep in mind these could be thousands or hundreds of thousands of meters, but I'm going to keep them small and say that we have location A with an x coordinate of 10 and a y coordinate of 5, and B with an x coordinate of 15 and a y coordinate of 10. Okay? So what I want to do is, before we jump into the equation, I want to actually diagram this out. All right, so we have our origin here, and I'll just say -5, -10, -15, -5, -10, -15, 5, 10, 15, 5, 10, 15. Right, so we have a, think of this literally like high school algebra and geometry, right? We have a coordinate system. Let's go ahead and plot these 2 points. So we'll plot A as red, so 10 on the x, 5 on the y, plots A there. B we'll plot in blue, 15 on the x, 10 in the y, we'll plot that there. Right, and so conceptually, what linear distance, what we're trying to measure, is the distance between these 2 points. Right, so this here, this is linear distance, right? Conceptually, this is the thing that we are trying to measure. Okay. So let's talk about the equation. The equation for linear distance, which I'm going to demark as D, is going to be the same as the square root of XA minus XB plus squared plus YA minus YB squared. All right, so let's go ahead and just plug the numbers into this equation, and then afterwards I want to give you a justification that'll tie in some basic mathematical principles that hopefully you already know, that will help you be able to justify, and if necessary, come up with this equation on your own. So xa minus xb is going to be 10 minus 5 quantity squared. So if we do 10 minus 5, or I'm sorry, 10 minus 15 quantity squared, plus ya is 5, minus yb is 10, quantity squared. Take the square root of that, right? So this is going to be negative 5 squared is 25. This is also going to be negative 5 squared is 25. Take the square root. So we have 25 squared plus 25. That's going to be the square root of 50. Which, if we do the math on that, is approximately equal to 7.07. Right, so this is our answer. Okay. So the equation, I think, is pretty straightforward, but just to understand why this equation works and be able to draw it back whenever you need to, I want to go back to this idea of this diagram over here. And what I want to do is I want to add in a third point, which we'll call C. And I want to add in our coordinates. So A was 10 and 5. Oh, that's really hard to read. Let's try that again. Right, A, we had 10 and 5. That's this point here. Right, B, we had 15 and 10. Now I want you to take a second, pause the video, and I want you to think about, given what we know, what the coordinates of C would have to be. Okay. Hopefully you've paused the video and thought through this, right? But C is on the same y level as A, so it's going to be pulling the y value from A. So we'll just denote that this is YA. It's going to be on the same x level as B, so it's going to be pulling the 15 from B. So I'm just going to keep track. This is XB, right? So hopefully I'm not using too many colors here, but what we've done is, if we connect these 3 points up together, you'll see that we formed a triangle. Right, a right triangle. And I'm going to make this a little bit bigger here so that we can see everything, right? So down here, right, we had C with 15 and 5. Right up here, we had B with 15 and 10. And then over here, right, we had A with 10 and 5. Right, and just to remind everybody, we were looking to measure, this was D. Now, looking at it from this perspective, right, you'll notice that D is the hypotenuse of the right triangle ABC. Okay? So what do we know about hypotenuse, right? We know that the hypotenuse is equal to, right, B squared plus C squared, right? A, B, C. This is Pythagorean theorem. Right. Well, if we relabel these sides as big A, big B, and big C, right? Well, we know B, right? The length of B is just the difference between this point and this point, right? So that is x of A minus x of b, right? This length here is this value here, right? Same thing with c, right? The difference between, right, y of a, which again, right, this is y of a, right? Sneaky, sneaky, because this is a straight line, this is y of a. So the difference between here and here, right, y of a minus y of b is equal to c. Right, so if we put these back in here, right, if b is just the difference between the x's, then the difference between the x's squared plus, right, c is just the difference between the y's. So the difference between the y's squared. What do we have over here? Ta-da! Difference between the x's squared plus the difference between the y's squared gives us our distance. This is the exact same thing as the Pythagorean theorem, but applied to coordinates rather than just lengths of a triangle. So hopefully this made sense. At the end of the day, this equation here is the thing to memorize. All this stuff over here is just some nice backstory that might help you understand and conceptualize where things are coming from and why they work the way that they do. So as always, if you have any questions, please reach out. Thank you.